All right, today what we're going to be talking about are linear inequalities. So when we're talking about linear inequalities, they're basically taking what we already know with graphing. So if we were to graph this, we would start at positive 1 and our slope's 2. So we'd go up 2 and to the right 1. And then obviously we can go down and to the left and then continue that pattern. So we're going to take this, but we're going to make it an inequality now. So what we're going to do is we're going to graph this line just like we would with an equal sign. But this time we're going to make it less than or equal to. So in doing that, we want to know when we graph our line, what amounts are less than or equal to. So it would be this side. And then if we were to make it y is greater than or equal to our line, that would be everything on this side. So you just lightly shade it in. So now we're going to figure out how we know which direction to shade. So what we're going to do first is step 1. We're going to graph a line by solving for y and using the slope and y-intercept, just like we've done before. Now you have two options when you draw the line. It can either be dotted or dashed or solid. Now we know that it's dotted or dashed if it's just less than or greater than. But it's solid if there is an equal underneath it. So less than or equal to or greater than or equal to. So to know which way to shade, there's a couple ways to do this. Here's one way to do it. Is if you know it is greater than or greater than and equal to, you're going to shade above your line. So if it's a positive slope, you're going to shade on this side. If it's a negative slope, you're going to shade on that side. If it's a zero slope, you're going to shade above it on top. And if it's undefined, you're going to shade to the right. So those are all the larger numbers. And if it's less than and equal to, you're going to shade below. So we use our positive slope, it's going to go underneath. Same with the negative slope. And if it's a zero slope, it's going to be under. And then if it's an undefined, it's going to be to the left. So all the parts that are less than, whatever that value is. Now, sometimes you may get a little confused on which way you need to go. So there's another way to do this. So first off, let's look at our equation. Y is greater than 1/2 x minus 3. So what I'm going to do first is I'm going to look at my equation and I'm going to pretend like this is an equal sign, but it's not. So I'm going to start at -3 and I'm going to go up 1 over 2, up 1 over 2, up 1 over 2. I ran out of space. So now let's go down and to the left, down 1, to the left 2. So I'm going to make it a dash line because it's not equal to. So when I do this, I'm just doing a dash line through your points. And we're supposed to, since it is greater than, we're supposed to shade above. But let's say you're not sure which way to go. What I like to do is I plug in a point that's not on your line. And if you get a true statement into your equation, you shade with the point. If you get a false statement with your inequality, excuse me, I said equation before, you're going to shade without the point. So what I'm going to do is I'm going to pick the point 0, 0. So if I pick the point 0, 0 and I plug it in or I substitute it in here, so my y is 0 and my x is 0. If I make those 0, I'm going to end up getting 0 is greater than -3. Well, is that true? Yes, it is. It's true. So we're going to shade the direction that has 0, 0 in it. So that's one way to think about it. And here we're going to do the same thing. We're going to graph this equation, but this time we're going to have a solid line because it's less than or equal to. So again, start at +1, go down 3, to the right 1, down 3, to the right 1, and then you can go up 3 and to the left 1. All right, so we've graphed it. We've used a solid line. Now we're going to pick a point that is not on the line. And if you notice, 0, 0 is not on the line. And if I were to substitute that in, 0 is less than or equal to negative 3 times 0 plus 1. I'm going to get 0 is less than or equal to 1. Well, that's true. So I'm going to shade on the side that has 0, 0 in it. And then I know it's going to be that direction. Or you could look up here and know that if it's a negative slope, you're going to shade on that side. So either way works in case you forget which way you need to shade. All right, so what I want you to do is I want you to try these, but I am going to tell you to be careful because you first have to get it into y equals mx plus b. So you need to, So you need to subtract 3x from both sides, and I'm going to get y is greater than negative 3x plus 2. Now you're going to go ahead and you're going to graph this. Positive 2, go down 3 to the right 1, and then continue your pattern. This will be dashed, just so you know. So go ahead, try that one. And then for this one, remember you need to get it to y equals mx plus b. So we're going to subtract x, and I've got negative 4y is less than or equal to negative x plus 8, and we're going to divide by negative 4. Well, remember, whenever you multiply or divide by negative 4, we have to flip the sign. So you're going to get y is greater than or equal, remember that's a negative 1 there, to 1/4 x minus 2. Now that we've got this, go ahead, you're going to graph and go up 1, 1, 2, 3, 4, and then you go down 1, 1, 2, 3, 4, plot your point, and then you're going to figure out which way to shade it. So don't forget, whenever you multiply or divide by a negative, we got to flip. All right, so now let's go to the next part. Now we're going to talk about line of best fit or linear regression. So sometimes we're given points and we need to find a pattern for it. So it could be a linear equation, exponential equation, we'll learn about that later. So we need to figure a line that fits our data best. So we're learning about something called a correlation coefficient. It's also known as the R value, so that's a little bit easier to say. It's basically saying how close the points are to the line of best fit or how well it fits the data. The closer the correlation is to 1 or negative 1, the better the fit. So if R equals 1 or R equals negative 1, the model is a perfect fit, meaning your points are all on your line of best fit. So the closer it is to those, it's strong. The further or the closer it is to 0 is considered weak. So if the slope is positive, the correlation coefficient, that's your R value, will be positive. If the slope is negative, the correlation coefficient will also be negative. So this is not the slope, it's just figuring out how good or bad the line is to the points. All right, so here's some examples. So again, if your R value is 1, your points are pretty close in the line. And if you notice here, I like to circle, make an oval around the points and draw a line down the middle. So if you notice, the points are all pretty close to the line. Now here we've got 0.05. Well, it's still a positive slope, but if you notice, your points are a little bit further spread out. 0, we have no idea which way the line's going, so it's no correlation. And then we go through on the other side. If it's a low or a weak correlation, your points are spread out more. And then here we got a little bit stronger correlation. Your points are closer together. And then here, these are all right on the line of best fit. All right, so let's look at some examples. So we're looking here, at 0.39. So first off, it is positive. So I'm going to look at my positive. So it could either be this one or this one. And we have 0.39 is kind of between here. So it's closer to the low. So we're going to say B is probably going to be the better fit because your points are spread out, but it is kind of a positive. Although truthfully, I would say this is probably closer to no correlation, but it is overall a positive. And then, so this one would be B. for C, if you notice, it's negative. So I know it would either be that one or that one. And negative 0.85 is really close, so it's closer to here. So we're definitely going to have a strong, all your points are going to be really close to that line. So this one should be C. And this one is close to like here. Oops, sorry. It's close to here. So we know that it's going to be a low or a weaker correlation, but it's still a negative. So this gives us the negative. So that'd be A. And then the last but not least, 0.69 is probably about right here. So it's positive. So I'm going to look here, and it's going to be a stronger correlation. So your points are going to be a little bit closer to there. All right, so what I want you to do is I want you to match the graphs to the points, and then you can use the examples from before, okay? But remember, is it positive or negative? That's definitely going to help you with the direction your points are going. All right, now we're going to talk about the line of best fit, which is the regression line. So we're actually going to use Desmos on this. And what we're going to do is we're going to make a table on Desmos, and then we're going to create a line of best fit. Now, you're lucky because they just did an update where we do not have to enter in that equation anymore. So we can actually just select an option, and it will go through, and it'll give you the linear regression from it. So to determine linear regression, we'll be entering real-life data and creating a line of best fit. So the line of best fit is a straight line drawn as close to our data points as possible. So like I said, if you were to do this by hand, you want to get a really tight oval around your points and then draw through the middle. All right, so what we're going to do first is we're going to do this problem, and I'm going to take all of these points and I'm going to enter them in on Desmos. So when you go to Desmos, maybe. There you go. So when you go to Desmos, you're going to hit this plus and you're going to go to where it says table. And from there, you're going to enter in your X's and your Y's. Now, I already did that, so you don't have to watch me do it. But after we hit this plus sign and you've entered in all your points to the table, you're going to go through, and if you notice, it already plotted some of your points for you, but we'd have to zoom out more to find it. But if you go to now, it looks like a few dots. If you click that button, we're going to use that to find the regression. So after you click that button, it's going to pull up this information. And this is the little option that you want to look at, and you want it to be linear regression. So here's the cool part. We've entered in our points on the table. We make sure that we have the option linear regression selected. And then we're going to look at it and it gives us the equation of the line. So that's pretty cool. So we've got this equation of a line, and then I want you to look at our R value. Our R value is really close to 1, so that means these points are a really good fit to your line of best fit. And you can see, and I hit the little search button. I hit that guy at the bottom so that so that way it kind of zoomed in on the points for you. So it's really cool. So now that you got all this information, now you can go back and we can actually start looking at what to put in. So for this, I know that my X's, I'm going to make, yeah, I'll just do black for the equation. Okay, so the line of best fit, we're going to round to the nearest hundredth. So I've got Y equals 4.87, X minus 2.37. And again, if you look at the equation, that's exactly what we've got here. I just rounded it to the nearest, and so this would be 7. All right, so now let's go back. So I just rounded all of that, and we said the correlation coefficient was 0.996. So remember, that's your R value. All right, so we want to know, using this equation, how much did the panda weigh in 7 months? Well, remember, months are your X values, so we're just going to substitute that information in. I meant to do, yeah, that's right. Usually I like to make blue for months. There we go. And minus All right, and then you just plug that into your calculator, and we know it's going to be 31.72 pounds. All right, so now it says, during what month will the panda weigh 70 pounds? Well, weight is your Y. I'm going to go back here and change my colors because you guys know I love to have pretty colors that coordinate with everything. Okay, we're back on track. All right, so now we want to know what month will the panda weigh 70 pounds. So we're going to do the same equation, but this time 70 is our Y. And then we're going to enter in all the other information. And then when you go through, you're going to add, I'm going to put this underneath here. And you get 72.37 equals 4.87x, and divide both sides by 4.87. I'm going to just move it over here so I have a little bit of space. And I get x equals 14.86. So we're going to say in the 14th month, because we haven't reached the 15th month yet, so during the 14th month. And then this bottom part just says round according to the table on the questions. So if you notice, these are all to whatever the table is going through. So we have here. So we're not going to round to a really long place value if your table isn't there. All right, so now this one has a little trick to it. So for the trick, it says number of movie tickets has increased. Table shows a number of tickets sold in millions. But this part right here is very important. So if you notice, 1998 is year 0. So when you cross this out, we're no longer saying that's 1998. We're saying this is the starting point, that's year 0. So 99 is 1 year since. And this is 2 years since 1998. 3 years, now watch it, 2003 is 5 years from 1998. So don't just start counting, make sure you know how many years since. Okay, and then Y is your ticket price. We're going to leave that as is. So let's go ahead, and when you enter in these points for your X, and then these points for your Y. So I already did that. So again, go to the little plus symbol, do the table, and enter in these points. Once you enter in those points, you're going to hit the line and do the linear regression. And here's your equation. So linear regression, we've got our equation here. We've got our R value of 0.9694. So now let's go ahead, let's enter in our information on here. So he said this is Y equals 25.20x plus 1284.55. And we said the correlation coefficient was 9694. So that's a pretty strong correlation to your points, and it's a positive slope. So if the ticket sales continue to increase, how many millions of dollars of tickets will be sold in 2010? Well, that's the year. So we're looking for how many millions of tickets sold. So if that's your X, but remember, it's not really 2010, it's actually $12 years. So it's actually 12 years since 1998. So we're going to go through and we're going to plug this in. And we are going to do Y equals 25.20 times 12. And so we're looking for Y, and you're going to get Y equals all right, so, oops, I forgot to put this here. I wrote it down over there, but I did not put it here. So 12 is that. Okay, so what you're going to do is you're going to take Desmos, and you're going to enter in your table. However, if you notice, it's talking about the optimal growth 8% per year, and then it's saying from 97 to 2003, but it's telling you this. So that means 1997 is actually 0. So this is going to be 1, 2, this 3, and these are just increasing by 1 year, so it's okay to count like this. All right, so when you're entering this on Desmos, use these values for X. All right, and then you're going to go through and you're going to enter in the rest of the information there. All right, oops. Wrong way, here we go. All right, so that is your linear inequalities and linear regression.